All right, lesson 2.4. So before we can talk about transformations, we need to know about what are called parent functions. And a parent function is just the simplest function before any transformations have taken place. So just the original function. And there's tons of different kinds, but we're going to focus on just a few in this lesson. So let's start out with a linear or just a straight line. F of x equals x. So if we go to, or y equals x. So if we just go in and type in y equals x, let's look at the table first and fill in some points. Okay, if y equals x, they're going to be the same. X and y. So this will give us a straight line. So this is the original line. And just draw that as straight as you can. So that's a linear function. A quadratic function, we have a whole unit devoted to quadratics. So if we go to y equals and we type in x squared, and we look at the table. So I'm just typing in y equals, and to get the table, you click second graph. Or you can just copy off of mine. Oh, sorry. All right, so if we graph this, looks like a U shape. Then we get into absolute value, the absolute value of x. So if I go back to y equals, there's a few places to find absolute value, but second window is one of them. And number 1 will give us absolute value. So this one, when it's graphed, will make like a V shape. A little bit different than quadratic. And then the last one is the square root of x. So f of x equals the square root of x. And if you look at the table, anytime there's a negative x, there's an error. Because you can't take the square root of a negative number. So it actually will start at 0. And really with this one, a lot of them are decimals. So I'm just going to get some that are whole numbers. So 0, 0, 1, 1, and 4, 2. And it's that shape. So that's what a square root looks like. So you've got to be able to, when you see a function, you've got to be able to recognize which of these 4 it is. So if you see absolute value bars, absolute value. Okay. If you see a square root, it's a square root function. If you see a squared, it's a quadratic function. But there's going to be some things added or subtracted that causes it to transform. Okay. So the first transformation is a translation, which just moves it, it slides it. Okay, left, right, up, or down. It just slides. It doesn't twist, doesn't get bigger, smaller, anything like that. So with a translation, we're going to be looking for numbers that are being added or subtracted. So for example, let's use a squared for example. I might have x plus or minus some number squared plus or minus some number. These would be a translation. And so depending on if it's added or subtracted, and depending on where that number is, we'll tell if it goes left, right, up, or down. So the first one, if the number is being added on the inside. So if it's being added inside or right with the x, that moves it left. If it's subtracted inside, that moves it right. Those are actually opposite what you would normally think. You think, oh, added goes right. It's opposite. For the left and right, it's opposite. So that would be like this first plus or minus that I've got. Now for the other ones, if I'm adding or subtracting on the outside, that moves up and down. So add outside moves up, not opposite from what you would think. And subtracted outside moves down. So we've got 3 examples here. We're going to tell what type of function it is. So which of these parent functions from the top, and then we're going to say how many it moves left, right, up, or down. So number 1, what is the parent function, or what function is it? Square root. Then I have this -1 is under the square root symbol, so that's technically inside. So if I subtracted 1, that's going to move right 1. And this +3, notice that's outside. So that would be up 3. I'm going to graph this to show you. Let's see. X. So we're going to look at the two graphs. The blue one's the original. And notice how we did go right 1, up 3. And I like to use that starting point that started at 0, 0 to kind of gauge that. So it went right 1, up 3. So number 2, what type of function? Quadratic, because I've got this squared. And then subtracting 2 on the inside. Subtract inside, moves right 2. And subtracting outside moves down 1. So whatever number is being subtracted, that's how many it moves. Number 3, what type of function is it? Absolute value. So adding 3 on the inside moves left 3. And subtracting outside, down 1. Are there any questions on translations? Let's go to the back. We're going to do a reflection. So a reflection flips an equation or a function across a line. The only two that we're going to look at are across the x-axis and the y-axis. So this will happen when there's a negative number, like a negative in front of the x. If the negative is outside of the function, then it reflects across the x-axis. If it's on the inside, it's the y-axis. So we've got 3 examples. We're going to tell what type of function it is and then tell which line it's reflected across. We could have some that are reflected across both. That's possible. So number 4, what type of function? Good. So is that x or y-axis? It is the x-axis because that negative is outside of the square root. And then number 5, what type of function? Absolute value. Reflected across what? Y-axis. Number 6, quadratic. And x or y? Y-axis, good. So it's a y-axis because that negative is there on the inside. All right. Then we're going to look at the last type of transformation, and that is a dilation. And this is wrong. That did not get changed. A dilation makes it stretches it. So basically think about when you've got a picture in PowerPoint or whatever, when you drag it across, you drag it and make it bigger, make it smaller. That's what a dilation does. So there's going to be a number being multiplied, either outside in the front or inside. So if that number is outside and it's bigger than 1. So for example, if we're multiplying by 2, if we're multiplying by 3 halves, you see a fraction and you automatically think that's less than 1. 3 halves is really like what decimal? 1.5. So that's bigger than 1. All right, so if you have numbers bigger than 1 and on the outside, that is what we call a vertical stretch. So we stretched it this way. Think about that picture that you have on PowerPoint, if you take the top or the bottom box and what happens if you have a picture of yourself and you stretch it up and down? Are you going to become really skinny or really fat? Skinny. It's going to make you look skinnier, yeah. All right. If the number is on the outside and it's less than 1, so example like a half, a third, numbers like that, that is going to be vertical compression. So instead of stretching it up and down, we're squishing it. You're going to get really, really wide if you do that to your picture. Next one, if it's on the inside but is greater than 1, that's going to be a horizontal compression. So we're squishing it in from the inside or from the sides, and you're getting skinny. All right, if it's greater or if it's on the inside but it's less than 1, this is a horizontal stretch. Let's look at some examples. Number 7, what type of function is that? Absolute value. Now that number, it's on the outside and it's bigger than 1. So this would be a vertical stretch. Number 8, what type of function? Good. That number that's being multiplied is on the inside and it's less than 1. So inside less than 1 is a horizontal stretch. And number 9, we have 2 things. We have a number, well, first off, what type of function is it? Quadratic. The number on the outside is less than 1. So this would be a vertical compression. And you can abbreviate if you want. And it also had a number on the inside that was greater than 1, which is a horizontal compression. So it got compressed, squished down, and squished in the sides. Now these last 6 examples put them all together. So you've got to be able to decipher what's happening here. I think you have the type of function figured out. So this one is absolute value. So what's one thing that you see that's happening? What do you see in the front? A negative. So what happens when the negative is in the front? So it's reflected across the x-axis. And I do want you to put reflected. I know in those 4, 5, and 6 we didn't, but we were talking about reflections there. This could be anything. So put reflected across x-axis. And then we also are adding 4, adding 2. Adding 4 inside. So if you add or subtract, those are your translations that we did first. So if we add 4 inside, what is that doing? Left 4, and then what's the 2? Up 2. Good. This one did not have another number being multiplied in front. Okay, so, or in front of the x, either one. So we didn't have any dilations here. Number 11. This is a quadratic. So what do we see in the very front? Yes, sorry. My bad. Lost my... All right, what's in the very front? A 1/2. So what does that mean? Vertical compression. Good. What do I see in the front of the x? A negative. All right, so what happens when there's a negative? Now, is that inside or outside? Inside. So it's going to be reflected across what? Good. Okay. And then I have a +3 and a +1. So that's going to move left 3, up 1. I'm going to do one more together, and then I'm going to let you work on the last 3 by yourself. I keep getting this crooked. There we go. All right. So outside, I have a negative. Well, I didn't write down what it was. This one is a quadratic. So that negative outside is reflected across the x-axis. and there's a 3 outside. So that's a number greater than 1 outside is going to be a vertical stretch. And then -6 plus 8, that's going to be right 6 up 8. Now, before I let you work on these last 3, I want to clarify something on number 13. This negative, that's technically outside. If it were inside, there would be parentheses around it like that. But it wasn't that way. So there's actually nothing inside on this one. There's a negative outside, and that's all. Just a negative number. So those parentheses are not there. So it's negative x squared minus 3. So I'm going to pause the video here on screen. All right, so number 13, you should have wrote down that it was a quadratic, reflected across the x-axis, and it moved down 3. Number 14, absolute value, there was a vertical compression, reflected across the y-axis, and it moved down 9. And number 15, it was a square root. It was reflected across both the x and the y-axis, and it moved down 11. Does anybody have any questions? Yes.
So it doesn't have to have like every part of it. So they don't have to be a vertical or horizontal.
Correct.
Okay.
You could have one or all.
Okay.
You might just move down and not left or right, or vice versa.
Is 14 vertical stretch because 3 is greater than 1? That's what
Yes.
I thought. Oh, I left it out.
I bet I am making all kinds of mistakes today. Yes.
So if there's a negative at the beginning, it doesn't count as a vertical or vertical stretch.
Right, because and up here, if we look in this chart, still can't see that, can you? It says the absolute value of the number tells us. So if that was like a -3, the negative part tells us it's reflected, but the absolute value of -3 is still +3. And so that would be up here. Yeah, just kind of ignore a negative when you're looking at the dilations.